Alright, before we dig into the concepts of the rectangular coordinate system, let's take a moment to recap a little bit of Algebra 1 basics. Many of you probably are already familiar with the term real number line, which is usually covered in most of the Algebra 1 or even pre-algebra courses in secondary schools worldwide, right? If so, real quick, I have a question for you guys. Can you articulate the purpose of using or introducing a real number line? Pause to organize your ideas for a while, and then I'll introduce my answer. Welcome back. Before I provide an answer, I want you to select one of your favorite real numbers. For the sake of illustration, let's assume that you've chosen -2. Now, consider this following question. Do you think of the number you chose, whatever it is, as an abstract and conceptual entity, or do you find it to be more like intuitive and visual? Though you may have some images directly popping into your mind when it comes to the number you picked, since a number itself is not directly visible, but rather represented by a symbol, I would say a number is an abstract and conceptual thing. Consequently, it seems reasonable to expect that someone would look for a more perceptive means of expressing real numbers. As a result, this led to the introduction of the real number line, which provides a concise way to represent every real number as a distinct point in this continuum. Furthermore, this enables the comparison of orders of the real numbers based on the relative positions of corresponding points. To illustrate the concepts more specifically, let's consider the example of -2 as mentioned earlier. In this case, our task is to represent this number as a point on the real number line. Do you think there is any sort of a parking lot for -2 on the linear continuum? I would say yes, there exists only one position for -2, precisely 2 units to the left of the origin. I hope you guys are familiar with the term units, as I won't provide a detailed explanation in this video, due to the massive content we need to cover. Even if you chose a different real number, such as Euler's number E, which is a rational but still a real number, there is also a designated position for it. In this case, the point should be around 2.7182818 and so forth, units to the right of the origin. So as far as it's a real number, regardless of the number you've chosen, you can assign it to a particular point. Some of you might be curious about representing imaginary numbers on geometric spaces, which is not going to be covered in today's class. Undoubtedly, that will be covered soon in this section of complex plane, since it's among the most crucial topics in pre-calculus. Anyway, you don't have to mind the imaginary numbers in today's class. At this time, we want to invert the order so that we can label each point on the real number line as a real number. Each point on this linear continuum receives its distinct numerical assignment, defined as the coordinate of a point. So to reply to the question I asked you guys at the beginning of this video, I would say that the real number line plays a basic role as a geometric framework, tool, or background, providing spaces for real numbers to be located as the formal points so that we can visualize them when